Hello everyone, in this video we are going to make this kind of motion graphics with procedural particle system, and in this video we will mainly explore these new collision nodes that are added to this particle system. So let's get started. So if you have assigned the extra nodes as asset library, then you can directly add the particle system from the asset browser. So from this you can directly add this particle system into your scene. So let's go to the geometry nodes. So as usual, this comes with this default scene setup. So this is the particle system and the nodes. So the brief overview of this is this particle system is divided into 5 sections. You have input section, which is this one. Then you have the particle system input node, forces section, particle output node, and then you have particle object where you're going to instance a different object onto the particles. And this shelf contain all the forces nodes. Here you have this particle utility nodes. Here is the node which is important, and it is mainly for the collision nodes. Okay, so let's get started. First we need to delete some of the things that we don't need. So let's delete the emitter, also this target object, and we don't need these forces. Okay, and also these nodes. Let me first add a new emitter object, and that is plane. So let's select that from this modified panel. So we have this. So let's go to the simulation section. So here we don't need to change anything. In the emission section, I'm going to make this emission from first frame to 50 frame. In the emitter section, this emitter is not animated, so we can disable this option and also lower this around maybe 20. This particle density. In this, I think we need to lower the size of these particles, and the rest of the settings are default. Okay, we will change these settings later in this video. So let's replace this cone with icosphere so that we have a better visualization for the collisions. And I think we don't need this rotation nodes. So let's go to the first frame and see the particles. See, we have the particles are bound onto this plane. Now they are not moving because their velocity is 0 and there is no force. So let's add the gravity force. So this is the uniform gravity force. So now it's going to move these particles downward like that. So let me hide this emitter object, and we're going to add another object that is going to be the plane for the collision. Okay, let me also make this particle system at the origin. Okay, now select this plane. So let me pin this setup and bring this plane into this. And now we're going to first add this collision force, and later we're going to also use this particle collision. So let's first explore this collision force node. Connect this geometry to geometry, and for the collision surface we're going to supply this plane. Okay, so now let's rerun the simulation. So now the particles are colliding with this plane. So these are the different settings for this node. So let's focus on this collision sides. Right now the particles are colliding with the front side of this plane, the side which is along the normal of the surface, this blue side, and the red one is the back side. So if I make this back and disable this front side, you will see that the particle go through this plane. However, if I rotate this plane, now they are facing the surface. See, they are colliding with this plane. Okay, and this is really handy feature, especially for certain kind of motion graphics where you want to keep the particle inside a box or something. So you can do that. Let me show you that. If I add a cube here, so let's move this down. Scale this along the z-axis, something like scale z and scale shift z, and move this somewhere here. So now select this cube. I'm going to hide the plane. So you will see that particle going to trap inside this cube. See, they are inside this cube. You can also move these trap particle into a different locations using the volume option of this particle output node. Okay, let me increase this lifetime of these particles. So that's why they are disappearing after 120 frame. Okay, now let's change back this to plane, and we don't need this cube here. So let's make this front side. Next setting is the selection. So basically you can define this selection per particle or onto this collision surface. So per particle means we can make some of the particle don't collide with this plane. Sorry, we need to search the random. So now some of the particles has a false flag for selection. So those particles will pass through this surface. See, only some of the particles are colliding with the plane. And you can also use this evaluate option. This option is first going to evaluate the selection onto the surface and then going to apply to the particles. So we can create a mask onto this surface and we can use that mask to control the selection and other parameters like bounce and friction. Okay, so let's do that. First we're going to create a mask for this plane and then later we're going to use here. So let's add a geometry nodes for the plane, the collision plane, and we need to divide this plane so that we can store the mask properly. Then we're going to add the string to curve node. Type here, let's say K, and let me see this K. It should be at the center and the middle. Size maybe around 1.5 or so. Then we need to realize this, and after that we're going to add the spline edge follow-up node. By the way, these nodes comes with this extra nodes. Okay, then we're going to add the store node, plug that into this and name this as mask. So let me show you this. We have this kind of mask, maybe this around 1.11, yeah, something like that. So we have this kind of mask, and I'm going to also add the material for this so that we can see the mask when the particle are colliding with this plane. Okay, so let me add the material to this. Let's call this as ground and select that material here. In the color we're going to use this attribute option. So make this as mask. So if we go to the material mode, we have this. Let me hide this face orientation thing. And in the particle system, let's add the named attribute node. Type here mask and plug that into the selection and enable this option. Okay, so now you will see that particle only going to collide in this white region, not in the black region. See, particle are passing through this plane in the black region, but they are colliding in the white region. And we can use this mask like in the bounce case and also in the friction. So let me first explain what is bounce. So if I just rotate this something like that, so bounce 1 means it's going to reflect from this surface with its velocity. If you make this less than 1, then it's going to bounce from the surface inelastically. Like means it is losing its velocity as it hit the surface. Okay, and if you make this 0, then basically particle hit the surface and slide along the surface according to their velocity or the force. And if you make this around, let's say 1.2 means greater than 1, then it's going to gain some velocity from the surface. See, their velocity get increased as they hit the surface. Just align this surface So if I rerun this, see their velocity is continuously increasing. So you can play with this, and in this case we're going to control this with this mask, and let's enable this evaluate bounce option, and let's go to this side. See, particle are only bouncing in the white region, not in this black region, because of this mask. And we can also use this in the friction. So 0 means there is no friction, and 1 means there is a lot of friction. Okay, and this friction is only going to affect the particle's velocity, which is parallel to the surface, or you can say the or particle motion, which is parallel to the surface. So if I make this friction 1, see their velocity which is along the surface get decreased, and to become more clear, if I make this bounce 0 and see the animation, see they just stuck onto this plane, and now you use this mask and enable this option. Now the white region is have more friction, and the black region is frictionless. See, particles are just stuck in this white region, and in the black region they are just sliding along the surface. We can also combine this with bounce by using this map range node. So we can make the particles less bounce in the white region and more bounce in the black region. And also we have to enable this evaluate option. See, they are bouncing in the black region, but they are less bouncing in the white region and also have more friction. Okay, so this is the simplest example to use this advanced feature. Next I will show you the particle features of this node. Let me disable this one and make this bounce 1 and friction 0. And in this particle section you have two features, avoid and preserve path. Void is basically particle going to avoid the surface based on this distance or the size. Means if I make this, let's say 1, then particle will bounce from the surface by this distance. And you can also use the size, basically the radius of the particles, as the distance for the surface. See, now they are not clipping through the plane because of this option. Okay, and the next is the preserve path. The preserve path option is going to calculate the exact new position of the particles based on its velocity. However, in some cases we need the particle to touch the surface. So for that kind of motion graphics, I have added this as an option, so you can disable that. Let me show you that. If we make this distance really small, and also let's make this radius small so that we have this tiny particles or something like that. And we're going to also use this tracer node so that we can see the path of the particles. So let's add the join geometry node and plug that into this. So if we run this with the preserve path, see, some of the particles are not touching the surface because they have to preserve the path based on their velocity. And this is true for all the particles. Okay. However, if I disable this preserve path option, you will see all the particles are touching the surface. Okay. So this is really nice feature. And it is also compatible with this distance or the size option. Means if I make this size, and let me make this one, so we have proper scale for the sphere. See, all the spheres are touching the surface. See, they have nice same distance. However, if we enable this preserve path, now all of them don't have the same distance from the surface because they have to preserve the path. which is physically correct, but sometimes we have to cheat the physics, so that's why this option is there. And the last is the really important settings, that is the advanced settings. Means in some cases, say the collision knot is not working properly or some of the particles may pass through, so you can increase the iterations or you can increase the threshold or both. If these settings doesn't help to improve the collisions, you can increase the sub steps in the simulation setting. Okay, so but most of the cases I found this work perfectly fine. Only a very thin mesh you need to increase the iterations or the sub steps. So for that kind of case you need to change these settings. So these are the settings of this collision node. And in the output side they output two flag, is collide and collide. Is collide is like when the particle collide to the surface, it come true and remain true for all its life. However, the collide flag is only for that movement. Means when the particle hit the surface, it become true, and for in the next frame it become false. So you can use these flags anywhere using this particle info node in this setup and particle material info node to utilize these flags inside the material. Okay, so we will come to these nodes. So now let's add these mask to this for bounce and this for friction. And let me see that, yeah, it's working. And let me slightly increase this plane so that all the particles are bouncing onto this plane, and also disable this tracer node that we don't need. And here I'm going to add the set smooth node, so we have a nice smooth spheres. Now let's add a material to these spheres, and then we're going to add the particle collision node. Okay, so this is the default material for the particle system. So we have this particle info material node, which is similar to particle info node that we have in Blender. It provides all the attributes of the particles here and also the collision attributes. We have another node that is particle action material node. So it provides all these action flags that you may need. So let me show you first the collide flag, is collide. So if I connect this to strength, you will see that how the color of these particles change as they collide with the plane. Okay, this plane. See, and if I connect this to collide flag, and you will see that when they hit the surface, only then this flag is true. See, but after some time, because they are continuously hitting the surface, that's why this all these particles have true flag. So that is the difference here. This node also provide a collide time, basically a clock that run after each collision. So you can use that to basically animate the material or something else, or to mix the materials. And it also provide a collide frame, and that you can use to basically shift some kind of animation. Okay, so now let's add the principal shader here, base color, and let me plug that into the surface. And here we don't need this yellow part, and for this color we're going to use the blue, and we're going to make this based on the velocity of the particles. Add the map range node so we have a better control over the velocity. Let me plug that into this and make this around 0.35. This should be 0. See, the particles have 0 velocity are this orange, and the particles that have non-zero velocity are blue. Now we're going to utilize the particle collision force node. Let's duplicate that, and that should be before the collision force node. You will see that these particles are colliding with themselves. So this is what this node do. So when the two particles are overlapping with each other based on their size, this force become effective and it's going to push those particles away. So you can control the strength with this, and you can also improve that particle collision by increasing this number of sub steps. Let's make this 2 or 3. You can increase that if you have a very large number of particles, or when the velocity is really high. So let me make this 2. I think 2 is enough. And another thing you can do is that, let me duplicate this particle info node, because this force become effective just after the birth of the particles. So that's why some of the particle just bounce away from this plane. We can utilize this age-based factor. So this factor is something like that. Let me show you first. See, it is slowly changing into from black to white with the age of the particle. So we can make this strength based on this age, means it is initially a 0 and slowly effective with the age of the particle, maybe around 0.1 or so. See, now most of the particles are onto this plane. And nice thing about this mask is that, means if I go to that setup, let me bring that. We can also animate this, means let me go to the first frame. We have this, and after some time we can, let's say, make this a 0, and those particles just move away from the plane. So you can animate that. You can use a different letter, change the letter as well. Let me do that after some time. Means let's say we have this K and we can make this S. Now they shift to the S letter. So things like that, you can do that with this particle system. This is it about the collision nodes. I hope the concept is clear to you and how to use them. Now I'll break down my project files. So let me go to this particle system. So we have these particles that I have shown you in the intro. See, the setup is very similar that I have shown. So we are emitting the particles from a plane, which is this plane. Okay, and after that they are colliding with this second plane, which is this one. Okay, so these are the simulation settings, emission settings. All the particles are emitted onto the first frame, and this is just the density of the particle, and here I'm using this random size for the particle. Okay, after that, in the force section we have gravity force, and I'm using this turbulence force to just add some variation to the particles motion. And here I'm using the particle force node. This is different from particle collision node. It makes the particle attractive or repulsive based on the sign of this strength. Means when it is positive, means they are going to repel each other. When it is negative, then they are going to attract each other. So now they are repelling each other. I want these particles to be slightly like uniformly distributed over this mask region. So that's why this force is added. And these are the just evaluated masks for this bounce region, friction, and these are the setting for the particle section. And here I'm using just the psychosphere with some rotational velocity or the angular velocity, and this is the material for this. And the second project file is this one. So here I make this totally procedural, means from this collision geometry, particles, and all this shader. Collision geometry is created with geometry nodes just from this spiral. Basically you can play with this. All things is going to follow with this setup. In the particle I used this geometry for the collision, which is this path. And for the emission I'm using this plane. This plane is basically emitting the particles, and all those particles are colliding with this geometry and moving downward. So let me play that. See, something like that. So these are the particle settings. Here we have gravity force, particle collision force, and collision force, making this force effective only after certain time based on this factor or age based factor. And here we have the psychosphere, and this is really simple setup for the lighting. So I render this with cycle render engine. So this is it about the collision nodes and these kind of motion graphics. I hope you learned something from this. You can get this project file and other my presets and project files from my Patreon page. See you in the next video. Happy noding. Bye.